Hello everyone. Welcome to session on selection sort. In this session, we are going to go through what selection sort algorithm is, a detailed approach with an example. We will code the approach in Python. Then we will see what is its time complexity and space complexity are. By the end of this session, you will have very good understanding of what selection sort is and how to implement in Python. Selection sort is an in-place comparison sorting algorithm. It is one of the simplest sorting algorithm. The approach would be given a list of integers or elements. We need to find the smallest element and swap it with first position. Then we will find the second smallest element, swap it with second position. Then we will find the third smallest element, swap it with third element. We will continue this process until all the elements are sorted. Let us see whatever we just discussed with an example. Initially, we are given a list of unsorted integers 8, 5, 2, 6, 9 and so on. These elements are at indexes 0, 1, 2, 3, 4 and so on. Right? Selection sort algorithm goes like this. First, we need to find the index with the minimum value. It is 7th index. Okay, then what we need to do? We need to swap the elements at 0th index and 7th index. Right? Then we need to find next minimum value. It is at 6th index. Then we need to swap the elements at first index and 6th index. We swapped the elements, right? Then we need to find the next smallest element. It is at second index. So we will swap the elements, right? So in this case, we are swapping the second index with second index, right? Then we need to find the next smallest element. It is at 5th index. So we will swap the values at third index and 5th index. Then we will find the next smallest element, right? It is at 8th index. So we are going to swap the elements of 4th and 8th index, right? We swapped the elements. If we observe in each iteration, the left side is becoming sorted sublist and the right side is unsorted sublist. So we will continue the process. So next smallest element is at 6th index, right? We need to swap the elements at 5th and 6th indexes, right? So then we will find the next smallest element and swap the elements. Then find the next smallest element, right? Which is at 7, which is at 9th index. So we will swap values at 7 and 9th indexes. Then find the next smallest element. It is at 9th index. So then swap the elements at 8th and 9th indexes. So by this time, all the elements are sorted and this is the final result. Let us implement selection sort in Python. We are given a list of unsorted integers. If you see the selection sort approach, in each iteration we used to find index with minimum value and swap it with first element of the unsorted sublist, right? That is what we were doing. So in each step we were getting a sorted sublist and unsorted sublist. So let us implement it. So we will have a function called as selection sort. It takes list of integer as the input. So as we discussed, for every element in the list, right? So we were doing two operations. The first one is find the index with minimum value. So we call it as minimum index, right? we will find the minimum index in the list. Let us implement it a bit later in a separate function. Then what we used to do, we were swapping the values at their indexes. So swap the minimum index value, right? So once we iterate through all the elements, we will have sorted list of integers, right? So let us now implement the find min index function. Find min index takes an array of integers, right, as the input. So it will get starting index of the unsorted sublist with length of the list, right? Once we have these inputs, so initially we take start as the minimum index. So we will loop through all the elements from start to length, and we keep updating the minimum index when we find the minimum element, right? So how do we do that? So we loop through all the elements from start to the length. So if we find an index which is less than current minimum index, right? So what we need to do, we just need to update the minimum index, right? So in this way we can find minimum index value for the specific loop. So finally we return the minimum index, right? So basically what we have done here, for every iteration find the minimum index and swap the values of the first position of the unsorted array with the minimum index value, right? So let us see if it works. Okay, now we got the sorted list of integers. Now let us see the time complexity and the space complexity for selection sort algorithm. So in the first loop, right, we were trying to iterate through all the elements, right? So this would become O of n, right? And in another loop, we were finding the minimum index, right? The time complexity would become O of n here. So the total time complexity would be O of n into O of n, that is O of n square. Now let us see the space complexity. If you observe, we were allocating constant additional memory, right, for storing minimum index or these additional index values, but we were not allocating any additional memory that is growing proportional to the length of the list, right? So we were always allocating the constant memory. So the space complexity would become O of 1. Here is the summary of selection sort. Selection sort is simple to implement. Its time complexity is O of n square. Space complexity is O of 1. Since the time complexity is O of n square, it is inefficient on large lists. That's it for selection sort. Have a great day.